trigonometric identities and equations. AS level maths again. Hope you guys are finding this useful. Drop us a like if it is, and let's begin. So we want to show that this annoying fraction is the same as this. You only want to work with the left hand side because you want to show it's equal to the right hand side. So you can kind of ignore it, but we want to use it partially. Because right now, we know the right hand side is all in terms of cos. That's all we need from it. And the left hand side is in terms of sine and cos. So, first thing, let's get sine squared in terms of cos squared. So while you're practicing, write out your identities every single time. And you should know that sine squared theta is equal to 1 minus cos squared theta. If you skip this step, that's fine. But if next year you're struggling to remember identities, come back to this video and say, oh, this is why he made me do it. So please listen to the advice, just write it down. I know it's long this year, it will compound next year. So let's just substitute it straight in and stop waffling. So we can put it all in. It's all over this. Expand the top, so it's going to give us minus 10 cos squared theta, minus 7 cos theta, and then this is going to give us 10 plus 2, which is 12, and then 3 plus 2 cos theta. We can then factorize the top because it's a hidden quadratic, minus 10a squared minus 7a plus 12. So we are going to have 2 and 5. So let's write one of them will be positive, one will be negative, and then we're going to have 3 and 4. Cool. So I've just done that in my head. Let's just pretend you didn't just sit there and watch that happen. One thing that's likely going to happen is that and that are going to make up this. And you can check because 4 times 3 is 12, minus 5 times 2 is minus 10. And what you're going to see happen is that if this factorizes like this, which it does, oh, that's not right, that's supposed to be 3 plus 2 cos. This and this can now cancel out, leaving us with that. So, if you're running low on time in your exam, assume that and that are going to be the factorized form of this. Don't always just jump to that because it might not necessarily be true. But let's say there's like 5 minutes left and you've got part B to do, which you can do without actually doing all of part A. Pick up as many marks you can and move on, because there might be a time when maximizing marks is more important than getting everything correct. So let's now clear this and move on to part B, because we have proven it. So the question says hence or otherwise. We are not going to do otherwise. If it says hence, like it did in GCSE, there's a reason for that, because this can be rewritten as this. So I'm going to rewrite this entire question as 4 minus 5 cos theta equals 4 plus 3 sine x. Now, we have a question with cos and sine. If you try to square both sides, you're going to be left with a very complicated looking. It wouldn't even be a quadratic because you'd have sine, cos, sine squared, and cos squared. But the other thing we can use is tan x equals sine x over cos x. So first, get rid of these 4s. They can both subtract. And then we can divide by cos and divide by 3. So if we divide by cos, we'll be left with tan x. And if we divide by 3, we'll be left with minus 5/3. So this is our graph. And I will just draw this out for you. Now, if you guys have been taught by a teacher the diagram, what's that diagram called? The cat diagram? You know, where you have the axes and one's cos, sine, tan. Yeah, ignore it. You probably hate it, I hate it. And even after completing a degree in maths, been tutoring for 10 years, and obviously doing my A-levels, I still can't use it. Draw the diagram, and it's between 0 and 360, so we are going to sketch tan out. There's the first bit, there's the second bit, there's the third bit, that's 90, that's 270, 180, 360. Now obviously if you're using pen and paper, it's a lot easier. That's y is tan x. Then you want y is minus 5/3, which is going to be here. So these are the 2 points you're looking for. But remember, the calculator is always going to give you the answer that's closer to 0, which in this case is going to be this answer here. So, cool. We will make sure our calculator is in degrees, do inverse tan of minus 5/3, and as I said, minus 59. That's good to get a pen. Minus 59. I'm going to quickly check. Does the question specify if it wants a certain amount of decimal places? No. So I'm going to leave those whole numbers because it was minus 59.0. Now tan's the most easiest one to work with. If you're not sure, pick 2 points. So this one and this one. Find out how the graph either reoccurs or find the symmetry. So for this, it adds 180. Oh, adds 180. And you can see that is always true. So to get from here to here, you're adding 180. And to get from here to here, you're adding 180. So to get our next two values, we are just going to do 180 minus 59, which gives us 121. And then we're going to add 180 to that, which will give us 301. Double check, is the question asking for anything else? Both answers between 0 and 360. It was kind of 3 steps, 1, 2, and 3. So yeah, we're done. Let me know if you find that useful. Let me know if you want to see a breakdown of how I use graphs rather than the CAS diagrams. That's what it's called, not CAT diagrams. And we can go through this in more detail. Otherwise, drop us a follow, like our videos, and hope it helps.